代表、各位专家，我们现在开始。
Representatives, thank you so much. We are going to resume the session.
大家听英语还是用听中文？
Successful opening of
听中文。
这个无所谓。刚刚你讲的是
this event means that we are going to support the dual carbon target. By the year 2030, we are going to reaching the carbon peaking, while by the year 2016, it is going to be the carbon neutrality. I think bamboo is going to be working together as one of the major energy resources as well as the agricultural resources. In today's forum, we have invited a lot of experts in the agriculture as well as the sustainable energy field to work on the sustainability of the bamboo resources. For today's side event, we aim at developing the carbon events to further facilitate the carbon neutrality. There are 3 organizing committees for today's event, which is the China Society for the Forestry, China Industrial Society for Bamboos, the Green Economic Research Institution for the International Bamboo and Rattan Center, while the cooperation and sponsoring institutions include the International Center for Bamboo and Rattan. Today, we have also invited the Xiongmao Culture and Bamboo Limited, among other different sponsors as the major and co-sponsors for today's events. Today, we are really honored to invite some of the experts in this field. So now I'm going to introduce all the distinguished guests. The first one is Professor Zhang Wenbiao from the Zhejiang Agriculture and Forestry University. Second one is Mr. Sheng Huichuan from the Zhejiang University. Third distinguished guest is Professor Zhou Xianbing from the Nanjing Forestry University. The fourth presenter is Mr. Ren Xueyong from Beijing Forestry University. Now we are going to start the reporting process. We'd like to give the floor to Professor Zhang Wenbiao from Zhejiang University of Agriculture and Forestry to report us the innovation and development of the carbon charcoals against the dual carbon background.
谢谢主持人刘志佳秘书长，大家好，
Thank you so much
我是
for the
张文彪，来
moderator,
自浙江农林大
Mr.
学。
Liu Zhijia.
今天给
I
大家
am
报告
Zhang
的题目
Wenbiao
是
coming from the Zhejiang
在
University of
沙滩背
Agriculture
景
and
下，
Forestry.
沙滩
Today I'm
产
going
业
to
如
give
何
you
创
an
新
introduction
和发
about the
展。
innovation and development of the bamboo charcoal under the
下面我
double
讲3个
carbon
方面，
background.
第一个
My
方面是背
report
景，
is going to be
第二
divided
个
into
创
three
新与
parts.
发展，
The first part
最
is
后一个
background,
讲一
second
下
part
展
is
望。
innovation and development.
首
The
先
third
讲
part
第一
is
个
the
方面，
outlook.
大家知道
Let's talk about the
竹子
first
是一
part.
种可再生的资
We all
源，
know that the bamboo is a
主要分布
regenerative
在亚太
renewable
地区、
resources,
非
which is
洲和
located
南美
in the
洲，
Asia-Pacific regions,
在
Africa
我
and
国
South
竹林面
America.
积和竹
In
子
our
产量
country,
是世界首位。
the total
同
area
时
of the bamboo
竹子
forest
在
and
能
total
源、
production
环
of
境
the
保护
bamboo is number
以
one
及
in
带
the
动
world.
就业、
At the
乡
same
村
time,
振兴、
we
农
also
民致富
provided
等
the
方面具有重要的意
environmental
义。
protection,
那么什么是竹
economic
炭？
benefits.
竹炭
So
是竹
what is
材
the
加
bamboo
工利用
charcoal?
领域
Bamboo
附加值
charcoal is
最
a
高
solid
的产
product
品之一。
obtained from the
它是利用竹材
pyrolysis
在
of
一
the
定的
bamboo
装
and its
备和
processing
工艺条
residue.
件下
It is one
制
of the
得的
technical
固体产
products
品
with the
就是
highest
竹炭，
utilization rate of
同
the
时
bamboo in the
还可以
bamboo
得到
processing
液
field.
体的产
At
品，
the
我们
same
称之
time,
为竹
we
作
can
业。
get some of the
还有一
fluid,
些
which is called
气
the
体产
bamboo
物，可以叫
wax
不煤
fluid.
气，可
There
以
are
供
other different
气、
solid
供热
product which
或
is
者发
called
电。
the
那么
charcoal,
在中
bamboo
国，
charcoals,
竹
which
炭的
can
历
be
史
burned
经历了5个阶
for
段。
the power
第一个
generation.
阶段是萌芽时期，
So in our
从
history,
1994
we
年到
have
2000年。
the different
第二
stages.
个阶段
The
是
first
从
stage is
2001
the
年
budding
到
stage, starting between
2010
1994
年
to the
属
year
于发展的
2000.
时期。 第
Second
3个
stage
阶段是
is the
转型升
development
级，
stage from the
从
year
2001
2009
年
to
到2015
2010.
年。 第4个阶段是快速发展时期，从2016年到2020年，那么到目前是处在一个跨越式的发展。那到目前为止，我们竹炭的生产和产品的销售已经遍布全球。在亚洲，除了中国以外，有日本、韩国、印度、老挝、越南、菲律宾、印度尼西亚、泰国、马来西亚等等。非洲有加纳、肯尼亚、坦桑尼亚、莫桑比克、马达加斯加，在我们南美国家的还有牙买加、哥伦比亚、厄瓜多尔和智利。那么还有一些国家，比如说像俄罗斯、加拿大、法国、新加坡、澳大利亚，它虽然没有竹炭的生产企业，但是它有这个产品的销售贸易。那到目前为止，中国已经开发了7大系列，300多种产品，从最初的竹炭的这个日用品，比如鞋垫、炭包，到的今天的洗涤护肤，还有添加剂。装饰材料，还有一些各种用途的竹子活性炭种类比较多。第2个方面，我们讲一下竹炭产业在这个双碳背景下如何发展，特别是2030年的碳达峰，2060年的碳中和。那么竹炭产业如何创新发展，也就是说，我们竹炭产业如何为双碳做点贡献？那我们首先，在20大报告中提出要加快实施创新驱动发展战略，构建更高效的科研体系，推动产业创新链、人才链的深度融合。在我们原有建立的竹炭产业化基地、竹炭联盟和竹炭协会之间，我们跟科研院所要进行强联合，产政学研的深度融合，以问题为导向，科技创新为抓手，不断的开发新技术和低碳环保的竹炭产品，助力我们乡村的振兴，推动竹炭产业更高质量的发展。那首先从装备角度，我们要继续开发自动化、连续化、智能化的这个生产设备，同时要围绕着节能减排和减少二氧化碳这个方向发展的装备。那比如说现在正在开发也在产业化中的氮气联产设备，就这个气可以共气共热，这个液体可以回收，实现资源的综合利用。这一方面的话，等一下我们南京林业大学周建斌教授会更加详细的介绍这个内容，这个一个综合的效益。这样子的话，才把我们这个竹材能够大量的这个消耗掉。那么我们这个装备，从目前的装备过程，还有部分二氧化碳的排放，所以我们这个今后发展的装备要把减少二氧化碳的排放，以及捕捉二氧化碳的装备，同时要开发这个标准化的设备，以便在我们全球各个国家的竹产业区推广应用。第2个方面，产品的话，我觉得竹子要大力的开发各类的竹子活性炭的产品，尤其是高性能的竹子活性炭来代替煤质活性炭，因为煤质活性炭有硫跟氮的氧化涡，他们好像没翻译，氮的氧化涡这个有环境污染，刘志佳是不是他们没翻译了？好像没听到翻译了，是不是断掉？代替煤质活性炭有污染，同时可以代替椰壳的活性炭，因为弥补这个资源的不足。不管了，还是好像。另外的话，我们可以开发这个竹炭纤维类的产品，利用竹炭的远红外功能，可以开发各类的内衣和保健的产品。代替部分纤维类的产品。另外，我们还要发展这个能源储能的这个材料。那我们可以利用竹炭去研究，特别是 竹子的碳叫竹叶炭，它可以很好的作为电极的材料，还可以开发半导体以及超级电容器的这个材料。另外，我们目前开发的这个碳材料还是属于无定型的碳材料，所以我们在今后开发大量开展这个基础研究，是否能够开发这个石墨烯、碳纳米管这类高性能、高机构的这个碳材料。那么前面刚刚讲这个，我们减少二氧化碳的排放，所以我们要开发高吸附性能的二氧化碳，同时我们是为了减少这个利用难度和成本，所以我们吸附了二氧化碳的这个碳，可以考虑在土壤的改良、建筑机构材料、混凝土或者水泥类的添加剂，还可以在其他方面的利用，实现就是说这个综合的利用。另外的话，我们现在可以利用纳米纤维素和超细碳粉的混合，开发一类薄膜高吸附性能的薄膜材料，来吸附 PM 的2.5和可以做一些这个过滤的材料，以及我们这个口罩的这个内层啊。我们这个研究看左边的这个图是这个没有这个薄膜材料，右边的话有薄膜材料，这个烟味这个非常的吸附的效果非常的好。那另外的话，我们可以利用这个碳材料，在原来碳板的基础上开发功能性的碳基材料，作为室内的装饰材料，主能的、负离子功效的，以及远红外发射力，还有屏蔽的材料，还有就是说净化的板材，能够代替我们木质人造板从源头上克服含游离甲醛，然后可以代替这个木塑板耐老化性差以及一些石塑板的应用。总之是一种新型的健康的环保的功能的这个材料，也是未来装饰材料发展的一个方向。另外，我们在制备碳的过程产生的一些副产品，竹醋液。那么竹醋液的话，主要是由有机砷、酮类、酚类、醛类等100多种这种有机的化合物。竹醋液在这个促进植物生长、去除异味等方面就有很好的作用，所以它可以广泛用在医疗、污水的处理、食物的保鲜以及植物的生长、保持植物的活性、改良土壤等等方面具有很好的这个作用。那么我们讲好的质量、好的技术需要一个好的这个标准，这个来保证。所以这个图的话，上面2幅图是2016年在北京开的 ISO/TC 296这个标委会这个第1次的会议。第2次的话，第1次会议基础上，我们确定要制定竹炭的国际标准。那么在2017年，在印度尼西亚雅加达首都开的，就是说第1次的这个年会来讨论竹炭标准的技术参数。第3次年会是2018年在 S1.5 的首都爱迪斯阿巴巴市这个开的，这个继续讨论这个考虑。那么在2019年的话，还在我们中国，在我们学校继续开这个我们竹炭第3组这个标准的讨论会啊。那么在这个同样在这2019年的话，然后在菲律宾开了这个会。那么经过这4次的会议，这个基本确定了这个竹炭标准，在2020年12月进行了颁布。这个的话就是说发布的这个竹炭系列标准的3个标准。那么在上一个10月底的话，正好颁布了刚刚完成的竹制活性炭的这个国际标准。我想这个标准的制定对于推动竹制活性炭的市场和贸易国际的影响力具有非常重要的作用。那么今后在这个竹炭领域，我觉得在竹炭的基本理化性能的测试方法，还有洗涤护肤添加剂、食品添加剂以及竹制活性炭的气象、液象方面， 还可以继续
additives
制
as
定
well as the
国际
cosmetics and food fields.
国
The
际
ISO is
标
also
准。
going to is going to make for the
最
activated
后，
carbon.
我想竹炭产业
And
包括竹
finally,
炭
I
是个
think that
绿色
for the
和
crop
低
bamboo
碳
and
的，
biocharcoal
所以我们
industries
希望在国
is
际
a green and
国
low
际间
carbon
各个国
industry.
家之间的相互
So
合
with
作，
everybody's
以及
efforts
各个科研院所、
in
各个学
international
科
cooperation,
交叉的合
bamboo
作， 大
biocharcoal
家
industries
以
will
及
have a
政府
wonderful
的
future.
共同努力下，所
We
以
also
进行
need
深度的
to
融合，
work in this
紧密
field
的结合，
for the
共同的
integrated
研发， 所以
development.
我们相信竹炭产业在未来一
So
定有
I
个美
believe
好的
the
前景。
bamboo industry is going to have a very promising future in the end.
谢谢大家，我的报告就
Thank
到
you
此
so
结
much.
束。
That concludes my report. Thank you very much, Professor.
谢谢。
So Professor Zhang is actually the head of the China Biochar Industry Association. Thank you so much for addressing us.
And we want to have a Q&A session at the end of the 5 presentation. With further ado, I would like to have the second speaker from Zhejiang University, and Mr. Sheng Kuichuan, to introduce us on the topic of clean production of bamboo briquetting charcoal and its utilization as solid fuel with high value added. Distinguished ladies and gentlemen, good morning to you all. Today, I would like to report you the clean production of bamboo briquetting charcoal and its utilization as solid fuel with high added value. Previously, my colleague and my friends just introduced you the current status quo of development of social economy with industrialization process. Now I would like to report you on the raw material research and development and application. As we know, the social and economic development of China brings the progress of industrialization, which further requires more raw materials and resources. And traditional fuels are in a shortage, and also the current resource utilization structure leads to massive pollution and waste. Now, in the era of low carbon green development, circular economy, carbon reduction, and carbon neutrality, and we are moving forward towards these directions as well. Here, I would like to show you the statistics in 2021 China energy consumption composition. So this is the China energy mix. Coal has been reduced from over 70% to 56%. And also, you have the natural gases, petrol, and hydropower, renewable energy, and nuclear power now taking 16.6%. So these are of critical importance to sustainable development. I've introduced you about the dual carbon targets in China, that is carbon emission by a peak by 2030 and carbon neutrality by 2060. We need to develop a low carbon economy, make our contribution to the world, and to reduce greenhouse gas emission, and to develop our economy in a manner of low carbon, low energy consumption, low pollution. In terms of biomass, it is the organic matter in the nature, refers to any renewable or recyclable organic material. Within the biomass or biomaterial, bamboo is one of the major category. Previously, we have the planted energy crops and woods, Now I list bamboo inside of them. Residues from food and feed crops, residues and waste of forestry and wood bamboo processing, aquatic plants, and etc. So, giving you the introduction here on the slide, the plants, unlike fossil fuel, they don't add actual carbon dioxide to the atmosphere when they burned. Most scientists believe too much CO2 is bad for the environment. So there will be zero CO2 emission from the burning of bamboo, it is believed by the public. And we can use bamboo as the new energy source to replace the petrol and oil and natural gases. So you can see on the slides, there are different types of bamboo processing residues in Anji County of Zhejiang province. These are the potter's residue, and these are the solid cutting and the bamboo cuts. And here, bamboo carbonization for charcoal. Human society using energy starts with the wood fiber, start with the charcoal. And this is the human and the origin of fire in the human society. In the early beginning, wood is a major source of energy for survival and development. In agriculture, in pottery making, copper, and alloy industry, steaming engine, etc. Everything starts with fire, with wood fire. Solid biomass like straws and the fruit peels, wood and powders, etc. Now, bamboo carbonization for charcoal. We have the charcoal, we have the biochar. They have very high value of heat. Charcoal has a very long history. You can understand as wood process after processing wood become charcoal, or you can understand it as a wood-like fiber material. But today, in my topic, I would like to say that charcoal as a solid fuel to replace coal and other conventional energy source to reduce carbon emission. And also, I would like to touch on biochar, which is very friendly to the environment and to the biosphere. It can be used for carbon capture, and it is really environment and ecological friendly. As mentioned by the other speaker, we have the heat from the external environment. It has been changed from the big molecule to small molecules, from biomass to bio-oil, and then to the biochars. Biomass pyrolysis refers to the thermochemical conversion that occurs when biomass is subjected to high temperature and oxygen deficient condition. We need to control the oxygen content in this process. It has been put into 4 stages: drying, endothermic, pre-decomposition, endothermic, at the temperature range of 150 to 275 degrees Celsius, and solid decomposition, exothermic at the temperature range of 275 to 475 Celsius degrees. And after cooling down, you will have a liquid product. The last stage is carbonization, exothermic, with a higher temperature. Bamboo carbonization for charcoal. By controlling the reaction condition, the reaction process can be adjusted to obtain different target products, such as solid, liquid, and gases. So we have two types here, non-oxygen carbonization. The bamboo raw material after drying, we will put into the oven or container with in the non-oxygen condition. We will warm up and heat the container and to have the decomposition of the bamboo material inside the container. So this is the more of the detailed chemical process or technical process of the production. And then the second is oxygen limited carbonization. And to be more specific, can be divided into different type of methods. An influencing factor of biomass pyrolysis: temperature, heating rate, pressure, residence time, type of feedstocks, and all this have the impact on the final charcoal produced. I mean the quantity and quality of the charcoal from bamboo carbonization. Still on the topic of the bamboo carbonization for charcoal, we have two different types of process. Bamboo briquette charcoal process. One is carbonized after bamboo densified, and the raw material shredding, drying, molding, densification, carbonization. This is the process, this is the flow. And the second one is charcoal formed after bamboo carbonized. The process is like this: raw material shredding to drying to carbonization to blending with the materials. And here are the details of these two processes. The two processes. The first one carbonized after bamboo densification. This is part of our R&D. So we are part of this R&D. So this is the wood or bamboo shredder. And this is the bamboo extruder. And these are the tools or components for replacement. And this is the bamboo briquette. In the 12th five-year plan, we have an project. This is the steam flow pneumatic continuous drying equipment for biomass particles. We put the ingredients in a proportional manner, and this is to on the other side is the production. Once we have the final products, we will put this is the briquette. We will put into the oven. Altogether, we have 70 ovens, and this is the final products, the charcoal. Clean production. This is of vital importance. It has enjoyed attention from the public, clean environment, and clean production. So all these emissions are prohibited. So all these facilities has been shut down. We have the in-process emission being recycled or being collected. Densified biofuel methods for sample preparation and methods for preparation of solid biofuel sample and test standard for evidentified biofuel. All standards, all national standards or industrial standards were qualified. Total moisture in general analysis sample, VOC content, ash content, bulk density, durability.
The process of the usage as well as the process of the bulking consumption, it is one of the major requirements. And these are some of the requirements which has been working through the long-term usage. Our country actually focusing on this standard making process. So we also came up with the standards for the length, section size, appearance quality, and also the density and the moisture content, as well as the ash content and also the carbon content. These are some of the carbonized material. And also their key indicators. We don't have a very strict national requirement. But we are not only, this is an industry not only for the exporting, we also need to importing the relevant materials. So actually we should be focusing on the heat volumes as well as the carbon concentrations. The second part is about the carbonization equipment. It mainly includes the carbonization columns, the moving carbonization furnace, the rotatory carbonization furnace, and also the fluorescent carbonization furnace, and so on. These kind of equipment needs to be, these carbon materials and also the bionic materials needs to be crunched. This is the raw materials entered from the upper side, so with the weight moving it from the downside, from the drying, pyrolysis, oxidations, and also carbonizations, the bamboo material gradually becomes the charcoals. We also have the rotary carbonization furnace. It is also known as the horizontal carbonization furnace. So because of the time limit, I am not elaborate one by one. I've been introducing you the bamboo furnaces. This is a project where the Zhejiang Jiju Biotech has been doing in the Anji, where it is a very huge project introduced by the China Central Television for not a few days ago. So there are two double rotary furnaces. One is for the dryness purpose. Another is for the heating material. So there are two rotary furnaces for the carbonization. We have also done some of the experiments. So here I have been attaching one photo. So this is the shaped biocharcoals, where we have actually used different compositions of the additions as well as the biocharcoals. This is with the water concentration biocharcoals. We are also using kind of a glues. The actual quality usage is around 3%. This is the water concentration. There are other different analyzing in this field. We are also working together with the companies to improve the bracket charcoal qualities. These are some of the prototypes which is being sold to the Middle East countries. This is actually the formed biocharcoals. And it is manufactured by one of the Zhejiang province's factories. These are some of the other different models and of the biocharcoals. This is actually the biocharcoals formed after the bamboo carbonized. These are some of the charcoals which can be used for the barbecues. This is what we call the Tanfu New Energy Co Limited. They provide us a lot of photos. This is actually a bamboo served as a raw material to come out as a formed biocharcoal. As Mr. and Professor Zhang Wenbiao has mentioned that he have led the drafting of the international standards of the bamboo charcoal. It mentioned that in our country, we are actually trying to voice ourselves out in terms of the international standard forming in the biocharcoal field and energy supply field. The standard was drafted very perfectly and it actually consumes a lot of effort and energy. So I'm also going to give you a few words about the applications of the biocharcoals. The energy application of the biocharcoals means that the biomass feedback, such as the agricultural and forestry residues, are decomposed by the heat under certain atmospheric conditions. For example, there are oxygen-free, oxygen-limited, and saturated streams, etc. And also the pressures. It is actually forming the solid product. We call this the biomass char, which is shortly for the biochar. The biochar consisted of the aromatic carbons and elemental carbons, and carbons with the graphite structures also contains more than 60% of the carbon. This has a very low solubility. And for the examples of the biochar, it applied to soil can increase the sequential time of the carbon in the soil, improve soil carbon storage capacity, and reduce the greenhouse gas emission, which is also increasing soil carbon exchange capacities, absorb nitrogen, phosphorus, and mineral ions, reducing the nutrient loss, maintain the balance of the soil ecosystem, thus improve the soil fertilities and increasing the crop yield. This is also very happening in terms of the growing of the plant. We have done massive work in this field. So this is one of the very hot discussed issues across the world. We have accumulated a lot of biochar applications in terms of the environmental recommendation. So the bio bamboo char can also be used for cooking rice meals as serving as the food additive. There are other different companies focusing on the additives for the animal field. This is a very hotly researched area. The industrializations of the biochar actually attracts a lot of experts in our industry. Let me summarize finally. The innovations of the bamboo carbonization is actually works in the clean production. And also the development of the newer bamboo charcoal product can be used for the clean manufacturing. There are some of the innovation methods. And also there are some of the development of the bamboo carbonization equipment. How can we produce a highly addictive carbon? It is not only going to serve as a part of the energy, we should also make it one part of the major supporting material. It needs all of the research institutions to work together. The automation process is it needs to be in line with the best and cutting-edge equipment. So the bioenergy can also work in the carbon capture and storage. How do we promote this industry to move together in this field? It needs our attention. Thank you so much. Thank you so much, Mr. Shang, for your wonderful report. So the biochar is one of the major bamboo-based carbon fixation material in China. I think in this report, it helps with the technical innovations in the carbon formations. Thank you so much, Mr. Sheng. Now we are going to give the floor to the Russian representatives, acclamation song, as well as Professor Zhu from the Nanjing Forestry University. The report is about the specifications of the bamboo technologies facilitating the double carbon technologies. So can you hear me? Yes, thank you so much for your kind introduction. Thank you so much for the organizers and the colleagues. I am going to give you a brief introduction of my work in this field. I am from the Nanjing Forestry University. So my topic is about the gasifications of the bamboo's multiple production technologies helps the double carbon targets to be translated into the near realities. The first part is the technological background. I think all of you have understood. So my introduction is actually including the following 6 parts. In terms of the technological background, the biocarbon target is actually being put forward by the President Xi Jinping 2 years ago. We are going to reach the carbon peaking by the year 2030 and carbon neutrality by 2060. This is actually one of the major targets President Xi Jinping has issued noted for 60 times in his public speech. I think it is a destination that our country must move forward. There are 3 questions in our country. The first one is actually the general production of the fossil fuels. And the coal is actually accounting for a large proportion of our energy structures. 50% of our energy is consumed by the coals. The third part is that we are a country need very large supply of the standard coals in a total of 5.3 billion standard coal tons, accounting for 30% of the global production. And let's talk about the manufacturing. So the biomass industry is actually an industry is going to be supplying by the agriculture and forestry industry. If we cannot use it properly, it is going to generate a very devastating effect. The corruptions as well as the fermentations of the biomass is going to be producing the methanes. The greenhouse gas effects of the methanes is over 20 times of the carbon dioxide, and also it's easier to trigger the forest fires. Every year in California in the United States, there are some of the forest fires. The environmental problem is actually a problem that covers multiple fronts. I'm also going to talk about the forest fires. What are the major reasons behind it? Because the current environmental protection theories and also the environmental protection theories means all of us needs to keep the wooden material on the mountains 100%. The fermentations and the corruptions of this material is going to definitely produce the methane. For 1 ton of this material, it is going to produce over 3 million tons of the methane. Once this methane is released to the air by a light flash, it is going to create a very devastating greenhouse gas effect. This is what Professor Zhang has introduced to you, the pyrolysis effect. If this material is reaching 300 degrees Celsius, a massive volume of the heat is going to be manufactured. Once there are some of the fires in the forest, the fire wave is lapping one wave after another, even creating even costing the lives of the firefighters. So we are going to talk about the carbon neutralities. There are three routes of the carbon neutralities. The first one is the absorption of the carbon neutrality. Second part is the carbon reduction. And the third technology is carbon fixations. The carbon fixation technology is actually focusing on the key technologies, including the CCS. I think bamboo can work as the best material for the carbon fixations. Let's look at the biomass industry in Finland. It is accounting for 85% of the biomass industries. In Switzerland, it is accounting for 36% of the total energy generations. The biggest coal-fired power plants in Britain are going to be transformed into a biomass burning materials. So before the carbon neutralization transformations, the biomass is going to be the major manufacturing product. The ratio is the highest. The second part is have a correct understanding of the biomass material.
This is the renewable bioenergy. That is 5 times of the world total energy consumption with great potential. And also we can see in China, there are 1.8 billion more of arable land, 4.8 million more of forests, and they can generate very much of biomaterials. This is the data from the from the National Bureau of Forestry. We will create more forestry in the future, and there will be more forest resources available for us. And also China is abundant in bamboo resources. According to the International Bamboo and Rattan Center, currently speaking, we have 100 million more of bamboo forestry. And this is the grain facilities, grain utilities, and all those of the waste. For example, from the wood furniture and from the green space, public green space. The biomass energy in China is very large in volume. If we manage the forest industry as the agriculture industry, we're going to create a huge potential and benefits out of the resources we're having now, and to support the carbon neutrality commitment made by China. Forestry is the water reservoir, is the basis or the origin for us to create money, create a fortune, create a stable food, and create carbon. So this is actually seeing the value of and multifunction of forest resources. We also understand that it can create employment. If we can collect all the wastes from the urban green space, from the roadside green space, or from the forest, mountain forest space, we can first of all create much more employment and generate incomes for farmers and peasants. On a yearly basis, 10 million new employments, and helping farmers to improve, to have a total improvement of income up to 3.5 trillion RMB. That equals to 350,000 per person per year. And also, we're trying to build rural revitalization by creating a beautiful city and urban and street environments, road environments, create a beautiful China, beautiful village, beautiful city, and beautiful landscape. Here, I would like to introduce you the biomass from agriculture and forestry industry, the characteristics and components and property of the biomass. The other straws and the other shells and the wood and trees and processing residues from the agriculture and forestry industry. So we call them in total biomass. In recent years, China has made some certain of progress in biomass, but however, it's still far from sufficiency. First of all, we have limited understanding of biomass. Many scholars and experts think biomass is insufficient in quality, cannot become a source for national energy mix. And the second, though the government or the country has spent much money and capital investment in biomass energy generation, it is too single manner of biomass to energy transformation with very low economic contribution. And we are losing confidence in many departments and investments. And the third is the rapid development of wind and solar power. Many projects are supported and sponsored by SOEs and central enterprises, etc. So giving biomass a little space to play. So this is the traditional biomass gasification technology. Our technology is much more advanced. We use the biomass and use our facility and process to transfer this big molecules into small molecules. And we also work with 2 US experts to have the green process of biomass production and bioenergy production. So the raw material, and also the end product will be biochar, and they can become the substrate component fertilizer. On the international community, it is a leading technology. In 2015, the California University of America, together with the Energy Commission of California and the Ministry of Agriculture in America, to start the biogasification. So this is the technology, a very flexible and diversified technology, support various modes. From the innovation perspective, it is a breakthrough that has not been made or achieved over the past 100 years, because traditional technologies produces residues and wastewater pollution, and also traditional active carbon need to burn a total volume of 2 ton coals instead of to produce the active carbons, and also it generates pollution emission, very low efficiency, and requires much labors. This is the biomass, flammable gas, or It is cleaner than the natural gases. It can be used for combustion engine, for heating, and for gas supply. And biochar, as mentioned by Professor Zhang and other speakers, it is very green. This is the microstructure, active carbon, and also other type of mechanical carbon used in engineering, used in home products. And this is a snapshot. Mr. Xi Jinping visited Jinggangshan rural area. We started this process in carbon fertilizer in the year 2002. And also we are one of the contributor to the industry standard of carbon fertilizer. And also we have been, our proposal has been approved or has been reviewed by some central leaders from the government. And our technology has been promoted by the ministry, central ministries. And this is the news release in Beijing. And this is the documents issued by the Ministry of Education. It has been reported by many central medias. This is Professor Chen Xu from the Agricultural University of China. Finally, I would like to introduce you the carbon-related, still about with the fertilizer, and this is about the power generation in different facilities in different areas in Hunan province and Jiangxi province, and this is in Anhui province and in Yunnan, and as we both understand, this is the gasification. You can create 0.5 ton of carbon to replace 0.5 ton of carbon. You can achieve 0.2 to 0.3 ton of biochar. And so this is very essential. This is the raw material cost. So it is very cost efficient, meanwhile generate economic benefits. Energy is the lifeline of the country, is one of the strategic resources of the country. In the process, we know that if we can utilize all the agriculture and forestry biomass to generate electricity, we can reduce CO2 emission by 6 billion tons. Thank you very much. This is the end. And you gave us the introduction from the bamboo. You gave us a very thorough introduction and also introduced us your technology working with the other partners. Thank you very much. I would like to give the floor to Beijing Forestry University. And his topic would be bamboo fluidized pyrolysis and multiple utilization of products. So I'm going to introduce you the fluidized pyrolysis of bamboo and multiple utilization of pyrolytic products. And bamboo is a good candidate plant for environmental afforestation, rural revitalization, and carbon sequestration, and can be used in many applications, particularly as energy resources.
One is major potential in supply as energy raw material. The bio oil is actually a normal grain sustainable oil providing the fundamental energy and resources. Professor Zhang Wenbiao have mentioned about its usage in the solid formations, the makings of the carbon solid formations. Exclamation Go introduced us the gasification process. I am going to focus on the liquidification of the oil product, of the bamboo product. Bio oil is going to be a novel green and sustainable oil providing for the fundamental energy and resources. It can serve as an energy alternative. It can also serve as a resources substitute. The major components carbon chain covers many fuel types, such as the gasoline, diesel, and fuel oils. The resources substitute is very rich in the phenols. Among other different chemical products, China University of Forestry is working together with the Sinopec research institutions. Not too long ago, we have been signing the cooperation agreement with Sinopec. So the forestry resources are going to be included as a part of the biochemicals and also the oil refineries in the Sinopec general distributions and landscapes. At the same time, it concentrates. The bamboo is also concentrated, composed of a lot of the biomass areas. From the production areas, the pyrolysis to oil is an effective measure of the biomass utilization with high efficiency for the large-scale centralized biorefineries. It is a very effective use from the biorefinery based on the pyrolysis technology. The biomasses after the pyrolysis technologies is turning into the liquid oils. It can increase the energy density by 3 to 5 times. If we increase these areas to higher levels, this can work for 10 times. The distribution methods is also working quite importantly, and the biomass materials, while it is densely distributed, we can turn it into the higher densely populated areas. It can be working in the centrally manufactured factories. This is also going to lower down the usage cost of the biomasses. So for the biomass, so how to convert the bamboo into the bio oil by fast pyrolysis? Currently, there are 3 technologies. The first one is the ablative. The second one is the CFB technologies. The third one is actually the vacuum rotation cones. Our team is actually focusing on the fluidized materials. So why do we use the fluidized bed as a reactor for bamboo pyrolysis? In the process of defibering, separating and cutting bamboo, a large amount of bamboo powder remains are generated, which can be converted into the bio-oil by fluidized pyrolysis. So while manufacturing it can generate a massive pounders, and these pounders is a very good heat material. By using them, it can be working in the carbon pyrolysis method. So here it is one of the bamboo manufacturing factories in Fujian province. While cutting the different materials into the different units, it is being manufactured into the different factories. So Professor Fu from our center has mentioned about long-term actually efficient usage of the bamboo materials. In the pre-treatment of the bamboo materials, it is very important for us to accumulate the raw materials. So for the pre-treatment, we actually tested about the fluidizations of the reactors. We find that bamboo particles and also powders can work as a very effective catalyst. Our team has teamed up with the fluid process of the bamboo and multiple utilizations of the porosity production. We add the biomass particles into the feeder, and once the biomass particles entered into the feeder, they are fluidized bed, and in which it reacted and separated. And for the fluorescence wipers, it actually entered into the catalytic reforming reactors, where we have the biochars entered into the separators as well as the condensers. For those who cannot condensate, it enters into the purifying tower to generate the biocoals and biomasses. So the pyrolysis is also generating the three types of these generations. So chars is actually coming from the char separations. This is one of the major products. The manufacturing process is around 50%. The gas production is around 10%. For the fluidized pyrolysis technologies, Beijing University of Forestry, BFU, is actually focusing on these biomasses. And through this treatment, we can get the three areas. For the gases, it is going to be providing the heating resources. And for the carbon material, it is going to be improving the qualities and compositions. In our team, we have systematically summarized the distribution of the bio-oils. And from the bio-oils, it can be refined and extracted to work as the activation technologies. It can also compose the different materials for the starch and also powders, and also works as the additives. Finally, we can make it as an environmentally friendly materials. For over decades, our team is being led by Professor Chen Qiying, and we actually work from the actual materials we focusing on the feedstock conversion, equipment, process, product, and also applications. These are some of the systematic work. In the clean energy sector, we have also focusing on the heat and mass transfer law. And also we have done the fundamental studies of the pyrolysis technologies. And in terms of the pyrolysis conversions, they are the coupling effect of the raw material and the process factors. We work on the interactions. And finally, in terms of the three major components of the fibers and the lignins, we actually make the lignin derivatives into some of the sugars. And also for the hemicellulose derivative, it is being used into some of the aromatics. For the different raw materials, after the decompositions, it actually goes into the different categories of the final product. And in terms of equipment, for solutions in equipment design, we actually came up with a small scale and large scale equipment, which covers from 1, 5, 10, 30, 200 kilometers per hour. And there are two types of the pyrolysis devices, which is quite mature in terms of the market performance. One is the fixed pyrolysis plant for large-scale centralized biomass processing. Another is mobile pyrolysis unit for small-scale dispersed biomass utilization. We can also build a biomass concentration furnace and for some of the forestries, and also some of the other different scarcely distributed areas. We can also promote the movable equipment. And this kind of mobile equipment is also going to be very helpful into the small scale treatment. By using these two methods, we can adapt to the biomass material, lower the transportation cost, and improve the using efficiency. So for the DP materials, the key equipment is being streamlined to fit the processing demand and connected according to its features. And there are other different connectivity. And for the reactors, the carbon biomass is also going to be improved, improving the reaction process for the biomasses. This is actually a systematic treatment for the combined liquefaction condensate. For the bio oil that we get, we then further analyzing its physical and chemical properties. This is an analyzing result of the bio oil components, where we can see very clearly that the bio oil, after the pyrolysis, it is going to be getting the major components and also the side components. According to these requirements, we can get some of the catalysts, as well as other different raw materials which in line with the biomass production. In terms of the energy usage, one major part is the fuel usage. Our team is also working on the water-oriented, and also we actually separate the water and oil. We can see some of the fermentation sugars, getting some of the degradable materials. And these materials, after further adding the hydrogen, we can get some of the additives. And for the bio oils, after further burning it and analyzing its biochemical features, we are going to find that the biomass is generally divided into the major categories, which is universal internationally. It is have the similar features with the number 2 fuel oil, making and paving the future way to replace the number 2 fuel oil in the future. We developed the bio-oil PR resin materials. We actually work on the bio-oil UF resin lower toxic wooden-based board glue. And this is the bio-oil starch glue home plate without the aniline hide glue. There are other different medical protection materials. There are other different protection materials. It can further improve the performance and the manufacturing of the bamboo materials. we have also actively facilitated the bamboo resins. We also lamented the board with the bio-oil resins. And in the laboratories, we have teamed up with some of the bamboo-based resins serving as the additives. After the site facilities as well as the heat pressures, we can achieving making some of the flow materials. This is actually lower down the cost. And for the external usage, we are also working on the bio-oil resins. Internationally speaking, we get a lot of companies' feedback. There is one company from Fujian who is jointly researching into this field together with us. We are hoping that this oil penetrating material is going to be very helpful for these water penetrating blocks. Its density is going to be condensed into the further usage.
We also use it on 3D printing. The bioresin for FDM-based 3D printing. We create the material with bioresin. Compare with other papers. So we can also produce more high-end printing by composing together, by combining with the other raw materials. So here you can see these are the products, the 3D printing final products. Also, to reduce the pure acrylic ester photosensitive resin plus bioresin and pure acrylic ester photosensitive resin. This is a comparison. We understand that bio-oil resin helps to reduce the cost, the carbon footprint, and it improve the cost effectiveness. And here are for bio protection or bio conservation. We can use it for better plantation. And also the bio-oil-based pad adhesive. It has been used in the International Horticultural Exhibition in 2019 in Beijing. And it has a total application area of 400 square meters. And the bio-oil organic cover pads used together with other materials and components to support the International Horticulture Exhibition. And the pads will be collected and returned to the fields. So this is renewable, as I mentioned. And here you can see this bio-oil for green and sustainable biofuel, bio-liquid fuel, and fuel cell create the hydrogen fuels. This is a on-campus project. Mainly use biocarbon and bio-oil. They use the material from the bio-oil, so it can use both the carbon as well as the bio oil. So this is a very novel methods to use the bio oil. This is the biochar for high value added activated carbon. We have a production base to develop a promotion to develop an example project. So the biochar is the powdered activated carbon and shaped carbon. Above are the achievements and products, and we have acquired awards and certificates from the Ministry of Science and Technology, Ministry of Education, and National Forestry and Grassland Administration, and also UNDP's accreditation. For so many years research and application, bamboo fast pyrolysis for bio oil production. We use bamboo as the raw material and bamboo particles as the raw material. And to utilize the major products bio oil to create green adhesives and to support bamboo board production. And the bamboo board will be recycled into the forest and for another circle. So this is a closed loop circulation and recycling application. Above has been welcomed by the government. They supported us with capital, and thank you very much for your listening. It's really an honor to be here and to share with all of you. Thanks to the presenter for your excellent introduction. You introduced us your point of view of fluidized, clean, and low carbon pyrolysis of bamboo and diversified utilization of pyrolic reproduction. So it's so many years of accumulation of your team. This is a very good way, or this inspires us to further understand the future use of bamboo materials. And because we need to end this discussion by 12:10. So I would like to take the list of time to finish my report. I'm the final presenter. My name is Liu Zhijiang. I'm from ICBR. For the years, I'm in the study of bamboo materials. I would like to report from the four perspectives. The first one, potential of bamboo, technology and products of bamboo, market demands, and product standards. Bamboo as a resource. We understand China is the biggest country to produce bamboo resources. China has over 837 species out of the total 11,042 species of bamboo plants in the world, with the area of bamboo forests registered at 7.01 million hectares, among which most of bamboo forest accounting for 70%. Currently speaking, economic bamboo species up to 50. We also have high mountain bamboo and all type of bamboos. They can be the resources to utilize in bamboo material. As mentioned, 7.01 million hectares from the statistic data of the State Forestry and Administration of China. We can produce daily wear, we can produce industry products. 50% and 70% of waste can be utilized in this way. But however, the current utilization of the waste is about 30%. So we are still, we need to catch up to tap the full potential of the entire width. The second is main type of bamboo solid fills, as introduced already by the other experts. Bamboo pellet is a type of densified biofuel used usually with a cylindrical form, random length, and typically 5 millimeter to 40 millimeter with broken ends, which is made from pulverized bamboo biomass with or without additives. So in this process, bamboo briquettes are typically made from compacted bamboo waste, either with or without binders. Bamboo charcoal, as mentioned, is a hardened, porous, highly carbonaceous product formed during the heating of bamboo briquettes in furnace and resort without and with limited process. Technology, one is compression. Because we understand bamboo residues are very difficult to handle, transport, store, and utilize in the original form. Densification increases the bulk density and are conducive to subsequent utilization. We invested properties of bamboo pellets, which are manufactured using different mechanics or processes. All property of bamboo pellets meet the requirements of US standards, and the gross calorific value of bamboo pellet meet the standard of German DIN 51731. Our standard is 18,500, better than the minimum requirements of DIN. Bamboo residue has low bulk density, high moisture content, and relatively low calorific value, limiting its widespread use. Torrefaction is called as a better pretreatment way to solve the issues associated with biomass feedstocks, which is a thermochemistry process under inert atmosphere at a temperature range of 200 to 300 degrees Celsius degrees. It can improve the energy density. We also invested the approximate and automated analysis of torrefied bamboo. Torrefaction improved the physical and chemical property of bamboo residues as a fuel by increasing its energy density, uniforming the quality of bamboo and making it less hydrophilic. Furthermore, torrefied bamboo is easily to brittle and grind compared to raw bamboo, because raw bamboo is even harder. That requires much more energy to brittle and grinding. The third, as we know, the moisture content is very high in raw bamboo. We can reduce the moisture content in the bamboo to avoid erosion or to avoid molding. On the slides, you can see the combustion behavior of bamboo, torrefied bamboo and coal. So you can see the bamboo burning. It can be cut into several phases: fibrine, burning, and charcoal burning. The second is torrefied bamboo burning. Under 40 degrees, it is only one burning process. Up to 60 degrees, there will be a biochar burning. So the torrefied bamboo moves to a higher temperature range, and the burning property is close to coal. This is the coal-firing behavior of torrefied bamboo and coal. In coal-firing bamboo and coal together,
these figures out because one, there is a very independent features of the bamboos and also the coals. So the separation, the fire process is actually quite separated. The material burns itself independently. The coal firing prevented bamboo and also the coal has a combustion zones. We also researched into the synergistic interactions. The synergistic interaction was also found between the bamboo and the torrefied bamboo and coal. It is just like the black curve, moving toward the lower temperature range. The presence of the bamboo and torrefied bamboo improves the thermochemical reactivities of the blend. The second method is introduced by all of you, which is called the pyrolysis. It is a very effective way to convert bamboo residues into the value-added biofuels. We find the pyrolysis mainly occurs at the temperature of 150 degrees centigrade to 400 degrees centigrade, and there are some of the degradations of the cells. Manufacturing the pyrolysis product includes some of the liquid liquid product as well as the gas product. Carbon bamboo-based material is one of the major types of the solid biofuels from the bamboo pyrolysis. The pyrolysis line controls the pyrolysis parameters during the manufacturing process of the molded charcoals, which is divided into the traditional brick kilns and mechanical kilns. So based on the current advantages, we are going to improve the manufacturing of fiber carbons, improve the burning efficiencies, and also reusing the gases, creating the clean manufacturing at the same time, and develop the gas line further. This is some of the directions that we are moving forward. This is a multiple carbon producing factors. From the factory perspective, for the domestic and international markets, the market of bamboo pellets is overlapped with wood and other biomass pellets. In 2019, the global market of the wooden pellets is about $10,491 US. It is expected to grow at a rate of 14.7% over the first few years, reaching a total market value of $23.604 USD in 2025. That is the global wood pellet market. Especially while the Russia-Ukraine conflict is damaging the Western energy industry, there are a higher demand for the particle-based burning material, where the major market is in North America, South America, and Europe. For the biomass materials, the total structure is around, the total tons is actually around 25 tons per kilogram. From the speed perspective, they grew 2% year by year from the year 2012 to the year 2027, reaching 8.11 billion USD. Based on the market, the countries can be divided into several regions, such as North America, Asia Pacific, as well as Middle East and America. For the project standards, there are 3 ISO standards are found on bamboo solid fields, including the ISO 21625. And there's no international standards and ISO standards for the bamboo particles. Moving into the next stage of work, we are going to launch into the bamboo particles standardization in the biochar. No matter for the forestry industry or the agriculture industry, we have some of the industrial standards for the bamboo particles, biomass particles. And there are very few biomass particles. So moving into the future, biomass particles is going to be a very good energy product where we should speed up the research, especially in terms of the energy conservation, highly and efficiently usage, processing and manufacturing. For the backup technology, it's a very good technology which can improve the properties and the performances. For the general performance, it can be evaluated comprehensively. For the biochar, it can also be used in the clean manufacturers, mechanications, and also the machine researchings. There are some of the side effects reusage to lower down the manufacturing cost, improving the competitiveness. That concludes my report. We also see some of the questions from the line. We have collected several questions, 1 question for each professor. So there are some questions to Professor Zhang Wenbiao. While during the process of the biomass, are they going to release the massive carbon dioxide? Is it very helpful in terms of the carbon neutralities and carbon emission reduction? Can you hear me? This is a very interesting question. My understanding is that during the carbon fixations of the biomass of the carbon material of the bamboo materials, if the carbon dioxide is used with the bamboo materials, I think it is going to be 30 to 40% of the total energy it produced. I've been also talking about the future equipment markets. There is going to be a massive production for the carbon reduction methods, but from the perspective of the energy conservations, we cannot exclude the possibilities. But there is a very small volume of the bamboos. Moving into the future, how do we recycle it? The third part I want to talk about is that, so after we have absorbed it, we are going to work it on the improvement of the soil quality. There are 3 levels of the usage of these problems. Very difficult to answer. This is also one of the major questions I want to dive into moving into the future. But generally speaking, there is less and less emission. I don't know whether my answer satisfies you. So Mr. Zhang, so after making the formation of the carbon, so what are the additives and what is the compositions of the other side product? I'm going to take your question. Thank you so much for your question. And the forming carbon charcoal, we are going to see the carbonization first, and we are going to add some of the glue additives. There are some of the starch additives applied in the early stage. Cornstarch which is being replaced by the potato starch. I think the ratio is around 3 to 3.5, 2 to 4% for a single unit. There are also other fibrosis, macroline fibrosis, which is being added on during the burning. If it is environmental friendly, it's going to be very helpful. For the second part, the carbon forming charcoals is going to be used in the barbecues, as well as widely used in the Arabic countries. And for the activized carbons, it can be applied to the environmental areas, the purifications of the gas, the removals of the potential materials. That is my short answer to your question. Thank you. So, Mr. Exclamation Joe, can you answer one question? During the multiple conjuncted production, how is the activated carbon being moved? And is the liquid free? What is the ratio between the liquid gas and also the solid? Yes, I've heard it. The first part is about during the gasification process. Can you hear me? The first question is that during the gasification process, the pyrolysis of the carbon is larger and higher compared with the traditional ones. From my over 20 years experience, are being compared and tested for multiple times. The gasification carbon, the pyrolysis is actually higher and larger. It can be reaching 600 to 650. For the general carbonization process, it is around 300. Second question is about during the pyrolysis, the ratios between the gas, between the water concentrations. Let's use the 10 to 15% of the water concentration as the benchmark. The gas is usually accounts for 35 to 40%. For the solid fixed, it's around 20 to 30%. For the liquid, it is also about 20 to 30%. The technology has developed into a stage where it can adjust the percentage according to the client's demand. I think this is a number which can be adjusted. A very short answer. We call it oxidation control gasification. That is to say, design the product according to the customer's demand. Now it's a question toward Mr. In. Compared with the industry-used diesels and also gasolines, what is the difference between the bio oils? Have you ever researched into the cost-performance ratio? Thank you so much for your answer. This is a very good question. Bio oil cost, according to our analyzing the different raw materials and different manufacturing resources, is around 2,000 RMB per ton. But for the currently combustion oil, the cost is around 4,000 to 5,000 RMB per ton. The composition is around 60 to 80%, according to the heat waves and heat volume. This actually works with the petrochemical background, but against the dual carbon background, a lot of energy sectors and electrification sectors, they are going to reaching the peak, and there are some of the caps on these burnings. That's the reason why these kind of biomasses can be extracted with a great potential. This kind of energy is what we call the zero carbon energy. The carbon is fixated, and so while we are working on the carbons, there are multiple. If we don't use it, it is going to be a carbon balance. And according to our initial research and the bio oil, there is a lot of oil concentration, which is much better than the traditional oil and petroleum. We also found that in some of the furnace, they are willing to add up some of the biomass materials.
This is for direct burning use. And also, according to our experience, we suggest bio oil to separate different ingredients in the bio oil. For example, phenotype. For example, PHA components or ingredients and other ingredients. We want to create the maximum of the efficiency of the product and tap the full economic potential from it. Pre-treatment of bio oil and to utilize the effective components. Thank you very much, Professor. Ladies and gentlemen, we are over time already. A final summary to conclude. Thank you very much for your participation, for your excellent and inspiring presentation, and very informative presentation. The topic from full perspective, biomaterial, biocarbon, clean production, added value, and gasification, fluidization, bamboo, solid material, and bamboo activated carbon. We have all these kind of updates from researchers, academies, and etc. This is of great importance and for our industry, and also contributing to the carbon neutrality and carbon peak commitments of China. Thank you very much again to the 5 speakers for your excellent and inspiring insights. And thanks to our audience as well for staying with us throughout this session. If you have future questions, you can talk.